the new unit's name is Similarity, and within Similarity, there's going to be ratios, and there's going to be proportions. You've already learned this. You learned it in middle school. You went over it again in algebra, so you're in familiar territory. So, look at the table, please, and determine the following. The ratio of teachers to students and the ratio of freshmen to seniors. So I'll give you a minute to do that. How do you write a ratio? What's a ratio? Yeah, very good, John. A number, and then dot, dot, and then a number. So if my ratio was that, would that be a final answer? Is that a simplified ratio? What would be the final answer? Do you know?
6 to 1.
6 to 1? You cancel the zeros out. You reduce. But if you don't know how to reduce it in your head, you could also go to your calculator and you could do 10 divided by 60 and then math, enter, and it'll reduce it for you. So you can do that on the warm-up as well. So I'm going to give you 2 minutes. There's 2 problems. You get 1 minute per problem. Celeste, how many teachers are there? How many teachers are there? Yep, 280. Jonathan, how many students are there? Oh, did you just get a calculator? Okay. Helen, how many students are there? Did y'all get that? 2,520? Good, thank you. Good. So this is a ratio. Really, a ratio is just a juxtaposition of 2 numbers. You're comparing 2 numbers. But this is not a reduced ratio. It's not a simplified ratio. So what you do is you go to your calculator and you type 280. Then what do you type? No. Divided by, very good, 2,520. And then math, enter. Oh, yeah. John, what'd you get? 1 to 9. So what's the ratio of teachers to students? There's 1 teacher for every 9 students. That's a pretty good ratio, 1 to 9.
You got a fraction.
Yeah, 1 to 9. So a ratio is a fraction. You can write it as a fraction. You could write it like that, or you could write it with a colon. Okay? Oh, there's my calculator trying to open. Raekwon, what did you get for the ratio of freshmen to seniors? 78 to 55. So there's 780 freshmen. And, ooh, some people must have moved on. Only 550 seniors. So, totally reduced, we're getting 78 to 55. Let's see what it looks like here. 780 divided by 550. Math.
Oh, see, that's
enter.
I hit enter.
Okay, oh yeah. Math, enter. Cool. 78 to 55. The calculator says you can write it like we talked about as a fraction or with a colon in between. Cool. Okay, we're going to take notes. What was our last unit called? Not just triangles. That was like 2 units ago.
Triangle theorem.
No. Oh my gosh, we just had a test on this. Congruent triangles. We were trying to decide if triangles were congruent, okay? We spent a whole unit on that. Now we're in a new unit, and we're going to try to decide if polygons/triangles are similar. So it's not the congruent triangle unit, it's the similar polygon/triangle unit. Oh, it looks like it's spelled wrong. The font's just really weird. So what does it mean to be similar?
The same.
The same? I thought congruent meant the same.
Sort of the same.
Sort of the same. That's a good way to phrase it.
I like
It looks the same. Do these look the same?
I like Oh.
How similar different from congruent?
They're smaller. Congruent.
They're just smaller. What?
Congruent is same size and same shape.
Mm-hmm.
Similarity.
Same. They're the same what? Shape, but different size. Very good. So yeah, all of these maintain the same shape. If these are similar, they better both be pentagons. If these are truly similar, they better both be, oh my gosh, hexagons. Yeah. So to be similar, it's really just taking a shape and you're going to enlarge it or reduce it. That's what John said. It's just smaller. So it's either an enlargement or a reduction of the same shape. All right, just for fun. That is his real shoe. Look how big that is. So another thing that we're going to be talking about in the similarity unit is scale factor. And so at the end of this lesson, we're going to be able to find the scale factor of an average man's shoe size to Shaq's shoe size. How much bigger is Shaq's shoe size than the average man's? We'll get to it at the end of the lesson. That's down on your paper. How much bigger do you think he is? Is he, 0.5 times as big? Is he 1 times as big? Is he 1.5? Is he 2? Is he 2.5? So that would mean, let me give an example. If your guess is 3, okay? Let's say someone's 6 foot tall. If Shaq is 3 times bigger than that person, then how tall is Shaq? 18 feet. Oh, I don't think that's realistic. So that might be a little big. You know what I'm saying? That's what, when you write a number down, it means multiply your height by that number, and you'll get Shaq's height. Okay, so just put your guess down, and we will go over it at the end of the lesson. What? Well, I can't tell you that right now. All right, where else is similarity in the real world? Have you ever, this is hard to see, but have you ever seen a mural painted on a wall or a building? A mural is a large picture. Don't you think that artist probably drew it small first? Yes, they did. Yes. Ask your art teacher. So they went freestyle. A lot of times they draw it on a small scale, and what do? They enlarge it. They usually don't make it different when they enlarge it. They just make it bigger. So they draw it small first to plan it out, and then they can make it bigger. Dollhouses are the opposite of that. A dollhouse, they look at a real house, and they shrink it. They make a model of it, and they make it smaller, and so that would be using scale factor as well. This one I really like. I don't know if you can tell what's going on here. This is called a wind something. Oh, it doesn't say what it is. Okay, but it's a wind tunnel. And what they do is they put a model airplane in there. And they blow the wind. And they find out, how does that model airplane react to this wind? Does it work? Is it functioning correctly? Now, wouldn't it cost a lot more money to do that with a real airplane in a real wind tunnel? Yes. So instead, they take a real airplane. They scale all the measurements down, so it's the exact same airplane, but just smaller. And then they put that one in the smaller wind tunnel, costs a lot less money, and then they can determine if any changes need to be made to the real airplane that costs thousands, millions of dollars. Okay. These are the words that are going to come up a lot in our unit. Just read those words. What do you think of?
Dilation is something whenever something gets big and small.
Big and small. Okay, so there's that enlargement and reduction we've been talking about. Have y'all heard that word before, dilation? Middle school, maybe? Probably not algebra. You heard it in algebra? Dilation, okay. Ooh, good point. Have you ever been to the eye doctor? Sometimes they dilate your eyes. What does that mean?
Expand.
So you have an iris and you have a pupil, right? And so it expands your pupil. Okay, good. I'm glad y'all knew what that was. Okay, wonderful. Yeah, good. Very good. Okay. All right, so we talked about this earlier. You don't need to write this down. These are congruent. Copy, paste. Copy, paste. Identical twins. These are similar. I can't just copy and paste, although if they are congruent, they're similar. But anyways, what would I do on my computer screen to create a similar figure? Shrink. Is there a button on my keyboard that says shrink? What do I do? What do I do? How do I shrink something?
Go around that square.
You drag the corner, right?
Yeah.
All of these shapes I'm creating right now are similar. All of them. This one is similar to 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 this one. Because I'm not changing the proportions. So that's how you would create a similar figure on a computer. How would you create a congruent one? Copy paste, like we've talked about. Okay. This you can write down in your notes if you would like. I do want you to know the difference between a ratio, just write ratio and draw a picture, and a proportion. And then you can just write the word proportion and draw a picture. What's the big difference between a ratio and a proportion? Oh, you're going too far. Just simpler than that. What's the difference? Look at those two. Starts with an E. Equal sign. One has an equal sign and one doesn't. An equal sign. So a ratio is simply a division problem. It's a quotient. You know how you have like sum, product. This is a quotient. Okay, so anyways, it's a quotient. Now, why does it say that b cannot equal 0? Well, okay, so it's a division. A divided by b. A can be whatever it wants. B can't equal 0. Do you know why? In algebra, it's illegal to divide by 0. No? You didn't learn that? Go to your calculator and do 5 divided by 0. It's going to say error. It's going to say error. So that's why it said, has a stipulation of b cannot equal 0. A proportion is simply saying a ratio equals a ratio. So this is a ratio all by its lonesome, just two numbers being compared. A proportion is comparing two ratios, not just two numbers, but two ratios. And of course, was it Helen was saying, when you actually solve for it, it has an equal sign. And to solve, we're going to do something that starts with C. Cross multiply and divide. Yep, we're going to do that a lot. Okay, this is the most important slide of the whole day. This is what you need to have in your notes. This is how we know if two polygons are similar. You're going to use this every day of the unit. This is really the biggest thing of the whole unit that you need to know. Now, take a look at this. I added that kind of without announcing it. That is the symbol for similar. So if I said that two triangles were congruent, I would say ABC is congruent to DEF. And I would use that symbol, an equal sign with a squiggly on top. Now, if I want to say that two triangles are similar, I do the same exact thing, but I just put a squiggly. So what does this symbol mean? Similar. Get rid of the equal sign. They're not equal anymore. They're just similar. They're not equal. This one, this box, says something about their angles, and this box says something about their sides. What do you think is true about the angles of similar figures? Let me go back to this handy-dandy slide. Ooh, good, John. When I drag it, and it gets larger and smaller. Oops, that's bad. That's not similar, right? I should have been holding down the shift button. Okay, so when I get larger and smaller, the sides are for sure changing, right? We all agree that the sides are changing. But are the angles changing? No. So let me make sure I maintain. Okay. Take a look at that angle. Can you tell that it's still the same? I don't know. Here, let me put this one. Let me bring this one to the front. And do the shortcut. Okay. Take a look at these angles. No, come on. No. There you go. Look. Oh, that matches. Look at that angle. Wow. It matches. So even though the size has changed, look how all those angles match perfectly. They are literally the same angle. So John knew it. And this slide will say that the angles, two polygons are similar if the angles are congruent. The angles have to match. The angles will match. The angles are congruent. Why did we add that tricky word corresponding in there? It just means, no, not the same thing. It just means match them up. It just means angle A is not going to be congruent to angle E, right? Because A is listed first and E is listed second. So the ones that go together are going to be congruent. A is going to be congruent to D. C is going to be congruent to F. B is going to be congruent to D. All right, so that was number one. Number one, that's how you know if two figures are similar. The second way you know, what do you think this box is going to say about its sides?
The sides or the sides?
Sides. The sides of the polygon. They are going to be different, but this box doesn't say two polygons are similar if their sides are different. Okay, but what about how long are they going to be? We had a slide 2 slides ago where you wrote down 2 words. It's one of those 2 words. Proportional. Very good. So the corresponding sides, they're not going to be congruent. They're going to be proportional. And we will practice that today. Have no fear. Corresponding sides are proportional. That's how you spell it. You start with pro. Proportional. That means their ratios will equal. Proportional. Okay. I'm going to skip that one. All right. Here's two polygons. Here you go. Are they similar?
Yes.
You can't say that without doing any math.
They're not.
Are they similar? So their angles have to be congruent. Are their angles congruent?
Yes.
Let me just tell you they're rectangles. So all of these are 90 and all of these are 90. Okay, so are their angles congruent? Yes. Okay, now are their sides proportional? We can't just guess at that. We have to actually mathematically decide if their sides are proportional. How could we do that? Set up a proportion.
No.
What do you want to do?
Let's do
Which ones do I match up?
8 and 5.
8 and 5, so the smallest one with the smallest one. Right? Okay. 8 is to 5 as 10 is to 7. Now, I want to know if that's a true statement or a false statement. There's 3 ways to check that. Give me a way. What were y'all saying? Cross multiply. Let's do it. What's 8 times 7?
Oh.
That's 8. Yeah, that's 8 times 6. Okay. What's 5 times 10? Oh my goodness, is that a true statement?
No.
56 does not equal 50. Are these polygons similar? No. So are all rectangles similar? No. You have to make sure their sides are proportional. The answer was no. Why was the answer no? They were not proportional. Okay, good. Write this down. This is a word, a vocab word. Scale factor. Yeah. Scale factor. Okay, you enlarged, you reduced, but how much did you enlarge it by? How much did you reduce it by? And that's what scale factor tells us. The scale factor is the ratio. I bolded that. It's a ratio. That means a fraction, guys. That transforms the first polygon to the second polygon. Transforms an average size guy to a shack size guy. Scale factor. I also want you to write this down. This is not something that like mathematicians have. Not everybody says it this way. But we say it this way at St. Paul's. We say to put the second over the first. That is how you get the scale factor. Some teachers say put the new over the old. And if you like that better, you can write new over old. But I like second over first because you're going to put the second figure over the first figure, whichever one comes first. Let's worry about this down here later. Let's not write that in our notes right now. Down there. Okay? So just write what a scale factor is and then make sure you put second over first and like circle it. This is really important. Let's practice finding some scale factors. Everybody look at A. Only look at A. I want to know the scale factor that gets me from here to here. From here to here. So what that's asking is saying, what can I do to 4? What can I multiply 4 by and end up with 6? 4 times 2, what's 4 times 2?
8.
Okay, so it's not 2. Where'd you get 1.5 from? Divide. So what did I just teach you to do? Put what over what? Second over first. So everybody write down 6 over 4. That's the scale factor, but that is not a final answer. Never, ever, ever write 6 over 4. What do? 6 divided by 4. Math, enter, enter. Or do it in your head. Divide by 2, divide by 2. What do you get? Saying 1.5 is not wrong, but scale factors should really be written as fractions. I like it better as a fraction. Keep it as a fraction. The answer to letter A is 3/2. Yes, that's 1.5. That's not wrong, but it's better to put scale factor as a fraction. Okay? All right, Raekwon, what do you want to do for B? Second over first. Now pay attention to where the arrow's going. Are we getting bigger or smaller, Raekwon? We're getting bigger. So just be careful. You don't want a small number as an answer. What do you want to do to get our scale factor? Tell me what to put over what.
Negative 8 over negative 2.
Sure. So he chose the x value. He could have chosen the y value. It doesn't matter which one you choose. But he put the second over the first because the arrow's going that way. You got to be careful. It was kind of tricky. What is negative 8 divided by negative 2? 4. The scale factor is 4. That means that heart is 4 times bigger than that heart. Have you ever seen the Grinch movie and it was like his heart was smaller, a certain number of times smaller than the normal heart, but then at the end it grew? Okay. Gio, do C for me. What's the scale factor? 2 over 7. Is that reduced? It is. Look, did my figure get bigger or smaller, guys? Smaller. So my number should be a small fraction. Don't write this down, but I do want you to look at this. This is what I was talking about the whole time. If you are getting bigger, your shape's getting bigger, your scale factor better be greater than 1. If you're getting smaller, your scale factor better be less than. It's always going to be greater than 0, so it'll be in between 0 and 1. And if you're staying the same, your scale factor is exactly 1. So if it's 1, you haven't changed it. If it's greater than 1, you got bigger. Less than 1, you got smaller. That's pretty easy. 1 is the number that tells you bigger or smaller. Raise your hand if you've ever played with Hot Wheels. I have. Yes? No? Never touched them? No? Okay. I don't even have any boys, but my girls like playing with Hot Wheels. They're fun. This is have you ever wondered, like, how much bigger a real car is than a Hot Wheels car? Because they use the same scale factor for all of them. So they picked a scale factor, and then what they do is they go to a real car. This one was just pretty, a real Lotus. And they measure everything, guys. They measure the headlights, they measure the diameter of the wheel, they measure the height, every detail they measure. And then they divide it by something. Put on your paper what your guess is. How much smaller do you think a toy Hot Wheels car is than a large one? What do you think the scale factor is? Is this one twice as big, 10 times as big, 100 times as big? Put your guess down. And the answer is, ready, drum roll? Drum roll on your desk. Come on, make it fun. Hey, do it. Y'all are lame. 1 to 64. All right.
I said 135.
35. Who was closer than 35? What'd you guess? Was anyone closer than 35 to 64? 64 was the answer. All right.
64?
Yeah. Well, why didn't you speak up? Okay, Gio gets one too. Hurry. 64 to 1 or 1 to 64. I'll take either of them.
Oh.
Okay.
So I was close.
Well, good. All right, let's solve some problems. Let's solve for x. You knew we had to get there somehow. Okay, triangle bat is similar to triangle mitt. Get what I did there? Bat.
Oh.
Anyways, solve for x. Go ahead and set up a proportion and solve for x. Go. Sabian, can you set up a proportion for those kids who are confused? Okay. I'll start you off. 3 is to 12 as, 4 is to x. So we did 3 is to 12 as 4 is to x. That's called a proportion. Yes. Good. Cross, multiply, and divide. Don't say the answer yet. So in your calculator, I want you to press 4 times 12 divided by 3. Cross, multiply, go across, multiply. 4 times 12
Got it.
divided by 3. What did you get, Chris? 16. Very good. X is 16. What is the scale factor? Now we better go look at our statement. Bat and mitt. Which one is listed first? Bat. And so mitt would be our second. So our scale factor is going to be second over first. Write down the scale factor. John, what's the scale factor? Second over first. Okay, what is it? But that's not reduced. Yeah, 1 to 4 or 1 over 4. Very good. Now, what if a student had done 12 over 3? What would they have gotten? Come on. Yeah, 4. Good. They would have gotten 4. Now, that would be wrong. Hey, you're wasting my time. That would be wrong because did that get smaller or bigger when it goes to mid? It got smaller. You don't want your scale factor to be 4. That means it got bigger. So use common sense when you're finding those scale factors. What do we have here? Quadrilateral math is to quadrilateral kids. Okay. I really had fun making these up. Richard, what is the scale factor? Find two sides that correspond, that go together, and put the second over the first. 10 over 12. Now, if you wrote that as your answer, I would count it wrong. Good. Thank you. Very good. 5 over 6 is the scale factor. Second over first. All right. Ooh, now we have to find the length of ds. That's what that means. So let's put an x there. Yasmin, set me up a proportion to find x. Just find the size that match. Okay, good. X over 18 equals, so we use that one and we use that one. Oh, good. You could use 5 over 6 or you could use 10 over 12. They're the same thing, okay? So you can just take right from the, I'm going to take from the picture, but you could totally use 5 over 6. Very good. All right, everybody, cross multiply and divide. Trinity, tell me what you get. Everybody, 10 times 18 divided by 12. 15. So that's how long ds is. Seth, what's the measure of angle T?
15.
No, angle, the angle. So that was a side. Ooh, good job. Here's what I need you to hear. The angles do not change. Say that. Angles do not change. Say it again. You don't use a scale factor on the angles. You don't set up a proportion with the angles. If this angle's 50 and it corresponds with this angle, then this angle is 50. The angles do not change. The angles do not change. The angles do not change. Alex, what's the measure of angle K? 10 degrees? 10 is a side length. What's the measure of angle K? Yeah, very good. K goes with M. If M is 90, then by golly, K is 90. Very good. All right, we are going to switch to the next lesson of the day. All right, so our next lesson is called Similar Triangles. And maybe I shouldn't put this anymore because everyone's obsessed with it. But that triangle is similar to that triangle. So on your currency, you're walking around with similar triangles. Okay. Okay, I don't even know where you want me to go with that. All right, similar triangles. Now, are these triangles similar?
No.
It looks like an enlargement or a reduction. How do we know though? Just like congruent triangles. How do we know? You done it. What could I do? What would I need to compare? What did we just learn? The angles should be the same.
It's not.
Uh-oh. Uh-oh. The angles have to be the same. And what has to be true about the sides? Proportional. Now, just like congruent triangles, do you think I'm going to make you measure all the sides and all the angles and all the sides and all the angles?
No.
There's going to be a shortcut. So this lesson is about the shortcut, not the congruent shortcut, but the similarity shortcuts. Here they are. You need to write these down in your notes. This is muy importante. These are new. These are different. Yes. These are new. Write it down. Okay, okay.
Slice.
Now, the squiggly is very important. We're not proving them congruent. We're proving them similar. So you have to put the squiggly or you get it wrong. Okay, what do you think the first one stands for? Angle, similarity. Now, did we have any angle ones for congruent triangles? No, angle actually is a false one, not congruent. Good. What does this stand for? Similar. Do you think that means the side needs to equal the side needs to equal the side? No, they need to be, start with a P, proportional. And this one stands for similarity. Okay. We're not going to go through each one because we already talked about them. Okay. Now, if you're trying, you're not getting one second. If you're trying to decide if these sides are proportional, how do you match up which sides go together? How do you match them up? What does it say?
Smallest is smallest,
Okay, all right. So, what's the smallest number in this triangle? Circle it. What's the smallest number in this triangle? Circle it. Okay, what's the medium one in this triangle? Square it. What's the medium one? Square it. And oval. Oh, you wanted to oval it? I just underlined it, but that's okay. So now that I've done that groundwork, I can literally just put circle over circle. Square over square. Underline over underline. I need you to check and see if these are proportional. They're all divisible by 3. You can just go through and divide each one and write down what you get. 3 divided by 1. 15 divided by 5. 27 divided by 9. Oh my goodness, if you get the same thing all 3 times, check. They are similar. So these would be guilty of being similar by side, 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 squiggle. No one else says squiggly, I didn't make it up, but that's not the technical mathematical term. Alright, for the rest of the class, we're just going to determine if the triangles are similar. No, we have.
Oh, similar.
Well, no, we have quite a few examples to get through.
That's similar.
Now, you wrote the 3 down, right?
Yep.
Is side, angle, side one of our choices?
No.
Yes.
Side, angle, side, squiggly?
Yes.
If you wrote them down, it's one of the 3. There's only 3 to keep track of, guys. That's awesome. 3. Now, do not be quick to judge. Just because it's side, angle, side, that doesn't mean the sides are proportional. You have to check to see if the sides are proportional. So let's check. 6 is to 10 as 9 is to 15. Go divide those in your calculator. Do 6 divided by 10. Do 9 divided by 15. See if you get the same answer both times. You can either cross multiply or you can just divide them both. What do you get both times? 0.6 and 0.6. So are these 2 triangles similar? What are they similar by? If you don't put the squiggly, you get it wrong. Try this one. Try it. Don't wait for me to work it. Try it. Divide some things in your calculator. Try this one. Divide some things. Small divided by small. Medium divided by medium. Large divided by large. Don't say the verdicts because then people will stop working. You're just dividing those in your head. Small. Medium. Large. What did you get when you did 6 divided by 14? 2.3 repeating? What about 9 divided by 21? 2.3 repeating. This is looking good, right? Do we have to check the third one?
Yeah.
Yes, you have to check the third one. 12 over 29. What do you get? What? 1.2? Were they that different? I thought I made them a lot more similar. No. 0.41. This is 0.42. Who's been doing my math? And this is...
You did them upside down.
Oh, you did it differently. That's fine. Either way, you're going to get the same thing. 0.42, 0.42, and 0.41. I made these really close. What did I write as my answer? P. Not possible, right? Or not proportional. That's a good one.
What about what you do?
Well, it'll have a blank, and you'll need to fill the blank in. Okay? Are the triangles similar?
Yes.
Remember our choices. We've got angle, angle, side, 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 and side, angle, side. Which one is it? I don't know this side. I don't know this side. What could I add to my picture, though? There's one thing I could add. They're sharing something. It's not a side. They're not sharing a side. An angle. They're sharing an angle. See how both triangles have this angle in common? So now we have side, angle, side, and then side, angle, side. We could make up numbers if we had time. And we could plug them in and we could be like, yeah, they really are proportional. So that one is side, angle, side, squiggly. We'll see that one again. All right, last one. I want it to be this one. Last one. You can do this. Are the triangles similar? What should every student be doing right now? Calculating what? Proportions on angles. These are angles, people. They're not sides. What should everyone? They should be using a theorem. The triangle, angle, sum theorem. Everyone should be using that. You should find the missing angle, and you should find the missing angle. Alejandro, what's one of the missing angles?
8.
8? 8? This is an 8-degree angle? 80. All right. Celeste, what's this missing angle? 60. Hey, guys, are these triangles similar?
Yes.
What are they similar by?
Angle.
Angle, angle, squiggly. All right.